everyone. In this video, we're going to take what we've talked about in previous videos about the 10 rule. And if you haven't watched those, you may want to take a look at them before viewing this video, because we're going to jump ahead into the middle grades and talk about some ideas that students sometimes have a hard time making sense of when it comes to dealing with powers of 10. So what I've written here is just a string of different problems to give you a chance to think about any patterns you might notice. And if you're working with kids, I'm going to pause for just a minute for you to let them see any patterns they can and just kind of talk about it. So pause the video and see what they come up with. Okay, so what a lot of people will say is that the exponent by the 10 is the number of zeros. Now that works for a little while, but it starts to break down as we start to transition to some later content. But if we go all the way back to what we talked about in the introductory video, we can actually restate that in a way that will then support us in learning some more complicated ideas. So if we say that 3 times 10 to the first is 30, that exponent is actually telling you how many place values the 3 is going to increase. Here it's 3 units of 1, and it increases by 1 place value to become 3 units of 10. And that's because 3 times 10 to the first is just 3 times 10, because the exponent is really how many powers of 10 you're multiplying by. Now let's use that rule and see if it works for this one. 3 times 10 to the second, okay, the exponent with the 10 is telling us that the 3 is going to increase by 2 place values now. So it started in the ones, 1 place value would be tens, 2 place values would be the hundreds. So it did work. And again, it's because what 3 times 10 to the second is really saying we're doing is 3 times 10 times 10. Take that same idea, extend it here. 3 times 10 to the third. That means the 3 increases by 3 place values. Ones go up to tens, hundreds, and then finally the thousands. And again, this would be 3 times 10 times 10 times 10. But if we take that rule and that pattern that we found and we apply it to a more difficult idea, kids in late elementary, early middle school can make sense of something that is a pretty complicated idea to understand conceptually, and that is why 3 times 10 to the 0 is 3. Now, a lot of people have learned that anything to the power of 0 is 1. That's certainly true, but early on, we could still use that same pattern and not have to memorize that rule by saying, well, if 3 times 10 to the first means the 3 goes up by 1 place value, to the second is 2, to the third is 3, to the fourth would be 4 place values. Well, this is just saying we're not increasing by any place values, so it's going to stay the same. Now, taking that idea and extending it actually helps explain something that's even more complicated than to the 0, and that is 3 times 10 to the negative 1. A lot of kids will want to say that it's negative 3, but if we think about negative as a symbol for opposite, these positive exponents were increasing the place value, so now we're going to decrease by 1 place value, so it becomes 3 tenths, because originally it was 3 ones. Extending it one more time, 3 times 10 to the negative second, building off the pattern we've been talking about, saying, okay, negative is going to indicate that we're doing the opposite, so instead of increasing, we're now decreasing by place values. We're going to decrease the 3 by 2 place values, so it's going to become 3 hundredths. And that's how the 10 rule that we started all the way back with just some whole numbers can be built up to learn some pretty complicated ideas that students learn in the middle grades.